The thing that you need to keep in mind when you are designing a plant is that each gold ore deposit is unique. So there must be a thorough understanding of the ore mineralogy in terms of the characteristics of the gold minerals, the gangue minerals, and the properties of the host rock as well. So a good place to start when you are selecting a processing route is to carry out a gold deportment study. And this is to establish the gold minerals that you have within your ore body, which will give you then an idea as to which processes are suitable. The gold deportment study also has the added benefit of establishing the acceptable tailings grade and identifying the speed. Okay, so on this slide, I've got a summary of the types of gold minerals that can be found in different modes of occurrence. So that can be as microscopic gold, as submicroscopic gold, and surface bound gold. I'm not really going to go into this long list, but during the ore mineralogy phase of your study, this is the types of minerals that you might encounter. Okay, so then this slide gives a breakdown of the microscopic gold minerals, showing the common gold minerals such as native gold, which is typically found as alluvial gold. There are also some gold alloys, such as those associated with PGM deposits, and gold amalgams from tectonic formations. Okay, so as previously stated, a gold deportment study is crucial for process selection. So the flow sheet on the left gives a summary of the gold deportment methodology, where each form of gold is analyzed for. By form of gold, I'm talking about microscopic gold, submicroscopic gold. They go into each of those different forms and identify the minerals associated with those. So the analysis includes your head gold analysis. A bulk modal analysis is also done to determine the composition of the ore. Next, it will include some sort of sizing analysis, where each size fraction is assayed to determine the distribution of coarse and fine-grained gold particles. Lastly, then, the recovery is estimated, and this is done by running gravity, flotation, and cyanidation test works. So the recovery that is then determined, if it is above 90%, then it is indicative of a high-grade free milling ore. But if the recovery is less than or equal to 80%, then the ore is more complex and requires more test work that simulates oxidative pretreatment processes in order to improve your plant recovery. Okay, so this slide just reiterates the full characterization test work, which needs to include your mineralogy tests, your ore textural tests, as well as metallurgical tests to get a full picture of the ore that is going to be treated within the plant. Also, to improve the performance of your operation, the data that you generate from your test work can be incorporated into a geometallurgical model. So this geometallurgical model rather, will consider the nature and characteristics of the ore, among other factors. And this is done to then predict your product volumes and qualities. Okay, the gold ore types. So gold ore is typically classified as free milling, complex, or refractory. So your free milling ores consist of oxides and your non-refractory sulfides. Then your complex and refractory ores contain varying compositions of auriferous base metals, and they also may be preg robbing as well. So on the right, I'm showing a diagram that basically ranks the different types of gold ores in the order of increase in refractoriness from top to bottom. So we can see that placers and the quartz vein ores are less refractory, they're more free milling. Then your most refractory ore is your carbonaceous sulfide ores. Okay, so for free milling ores, the typical processing methods applied are comminution, gravity concentration, flotation, leaching, and then some sort of concentration or purification stage, followed by recovery and finally the refining of your gold. Okay, then for complex and refractory ores, they require some form of oxidative pretreatment because they cannot be directly treated by cyanidation like free milling ores can. So the typical methods that are used are your thermal treatment, oxidative treatment, chemical treatment, and physical treatment. So thermal treatment is done by roasting, pyrolysis, and by smelting. Then your oxidative treatment